Okay, I started the recording. Few students are missing today due to excused absence. I should be seeing it in your end shortly. Just hold on there. Um, all right. Zeroni missed the first class. Actually, two classes happened. First class I didn't teach. The second class, I started with the interest stuff. I had a PowerPoint presentation. Um, so the other thing, let me quickly show it to you guys. Okay, just 1 second. What happened in last class? Um, yep. So that's what we did in last class. Okay. Just for everyone. Okay. We reviewed the differentiation and integration equations. Okay. We have done some of the theory, the basic equations for position, velocity, acceleration, deceleration. We've seen a PowerPoint over there. We've seen what means uniform velocity, right? When there is no acceleration, we derive that equation for that one, right? At that point, kind of is stopped, okay? So let's just start. So this is our lecture today. Yep, here. As you know, I can't share the I can share this OneNote. I explained it in last class, but I'm doing the recording today. Okay, so I'll upload the MP4 link, YouTube link. Okay, in Brightspace, and you can do closed caption over there. Okay, in YouTube. So that is that. Let's just start from here. Any question with the previous class note? I mean, four of you were here before. Any questions? No, you're good. All right, so the thing that we'll start today, non-uniform acceleration. You guys remember the uniform velocity? Okay, so the non-uniform acceleration, let's start with an example. Say like A is acceleration, if you remember that, equal 27 t to the power 4 plus pi. All right. So here, obviously, to get the velocity out of it, what are you going to do? Use the equation for A, which is A equal derivative of velocity with respect to time t. Let's remember that, right? And then we're going to rearrange. Every time you'd like to explore some of the things, you either have to do derivation or integration. You know that from last class, right? And you're going to do what? You're going to do the integration. Now, here's the thing. When you do the integration, this A, because it's non-uniform, A is the acceleration, it needs to be inside, the integration, right? You can just take it out because it's not a constant, if you remember it. All right, so it needs to be inside. So what you're gonna do next, you're gonna obviously start to plug the value of the A is the acceleration, which is 27 t to the power 4 plus pi. And now it comes to the knowledge of integration. And you gotta use the limit, upper and lower limit for both this integration in both sides, right? For velocity, the limits are initial velocity to final velocity, which is v0 and v, right? And for acceleration, the left side one, since it's a function of time, your initial time, which would be maybe 0 or t0, whatever way you want to say, to t, time t. So those are two limits. Okay. So the next thing is you gotta, on the left side of the integration, you gotta separate those two different parameters because those are added together, right? So which would be obviously 0 to t. Then you have this 27 t to the power 4 plus obviously dt here. It looks like a little bit congested. Let me rewrite it. So dt plus pi dt, and the limit is still the same. Okay, I'm rewriting the integration, and you have this v0 by v and dv, right? I haven't done any part of the integration yet. I just redistribute them. Addition rule, right? If you remember from integration. Okay, so then what? Then anytime you have a constant inside the integration, you don't do integration, constant integration, you just take it out from the integration, right? So you have this 27, we're going to take it out for sure. And then you're going to keep the t to the power 4 dt 0 to t, those are the limits. Pi, you're going to take it out. Pi is a constant, right? 3.14 blah blah. So 0 to t dt, and then you see that I'm going to keep same in the right side. I could have done the right side before, but just want to do all of them in one setting, right? So if you remember from last class, again, we did the review, if you remember that. So if you have a x to the power n dx, the integration result become what? X to the power n plus 1 divided by n plus 1. This n plus 1 is the power of x, right? You can put any number for n, say like n equal to 2, n equal to 3, n equal to 1, doesn't really matter, okay? Does it make sense? All right, to give you any further, again, we'll be doing it all the time today. So like x to the power, instead of n, you have 3. So in that case, I'm putting a line in between, so there's a separate, you'll understand it. In that case, you have this x to the power, this 3 plus 1 divided by 3 plus 1, which would be obviously x to the power 4 divided by 4, right? That's the basic integration you learned. Everyone? Till you know you're good? Getting it, right? All right, perfect. So then what do you want to do? You'd like to do the same here on this integration. You have t to the power 4. So if you have t to the power 4, yes. Okay, so yeah, I got to actually show the right thing as well. Yeah. So you see, this t to the power 4 can be considered as like x to the power n, in this case t to the power 4. So you're gonna do pretty much the similar thing, 4 plus 1 divided by 4 plus 1, right? And you have a limit which is 0 to t. You guys learned this thing in integration in calculus, right? Calc 2 or calc, I forgot, calc 1, whatever you said in last class. That's the place you learned, obviously. And then you have this t 0 to t. And this part I did review in last class. If you still struggle, as I said, just come talk with me. I'm gonna give you the understanding in person. Then next, what are you gonna do? You want me to do it, or you can do it, right? So 4 plus 1 is 5. Everybody know this, right? So t to the power 5 divided by 5, right? And you multiply 27 is just algebra, right? From this point on, it's just algebra. What's our goal here is to find the final velocity, right? If we have a non-uniform acceleration, given as the equation with a equal 27 t to the power 4 plus pi, t here obviously the time, right? You can do these steps, eventually you would be getting the final velocity equation. Is it clear? Now, is it universal for every problem? No, not really. This is an isolated single case, right? Where you are given with a relationship or acceleration relationship with time, right? Everything's good? No? Okay. So, and then the next steps are simply algebra. I'm going to do the algebra. Please let me know if you have any question with the algebra that I'm doing now. T to the power 5, and then, you have a limit, upper limit and lower limit. You remember the integration? You just plug the upper limit minus lower limit, right? So the lower limit is 0. So 0 to the power 5 divided by 5, right? I'm trying to be very descriptive. All right, plus pi, so t minus 0, right? And then v minus v0. Everybody agree with me on that? All right. And then the next step would be 27 t to the power 5 divided by 5. If you do a power of 0 to the power something, it becomes 0. So the right thing will gonna go away. There is no existence, right? then you have this pi t, and then you have this v minus v0. These are the side nodes, right? I wish I could have used different color. I need to stick with only the black color, so side nodes. I explained it in last class why. Side nodes, so you can see the different colors. It represents different things. Okay, because of the space limitation, I can just go any further. You're seeing I'm going on the right side, right? Just putting the arrow. It's clear to everyone, right? Okay, so then what I'll be doing, I'll just rearrange things. So I have this right side v minus v0, so I'll keep the v as it is, then v0, right, plus that 27 t to the power 5 divided by 5 plus pi t. Okay, I just rearrange things. I did nothing. Okay, here, so that's your equation. I can kind of put a mark here. That's your equation for what? That's your equation for the final velocities, right? What is the initial velocity? V0. Make sure you understand what happened here. First of all, this is a non-uniform acceleration. Non-uniform acceleration means what? The acceleration value can change, right? It's not uniform, right? So if that's the case, the equation was given here, a equals 27 t to the power 4, t is the time. Okay, to the power 4, you understand, it's a polynomial plus pi, right? So then what you did, you just simply use the derivative relationship with a and b, right? A equal to dv over dt. You rearrange things, you did some integration, you come up with the final velocity equation, okay? In terms of time, okay? So that's your goal. So most of the time you'll be doing this sort of thing, okay? You'll be getting a homework soon, okay? I just don't wanna give it to you right away, okay? But you'll be getting it soon. Let me get my notes again. So the next thing, that the problem that I'll be doing, any question with this one that we did, the final velocity for non-uniform acceleration. All right, so the next thing that we'd be doing here, if there's no question, then there's a typo here. Okay, the problem, the first problem that we are doing in this semester, okay, let's do a problem, real problem. So if a particle has an initial velocity v0 is given, let me start writing at the same time when I'm talking. So if the particle has an initial velocity, let me highlight that here, given as 12 feet per second, right? All right, and then by the way, if you come late, I mean not come on time in class, it's going to happen with anyone. I'm not pointing anyone, just to get clarified. Okay, if you come late, just to save class time, and those who come early to respect their time, I don't want to go really slow in terms of giving you more and more time on writing. That's not fair to any one of you. You understand that, right? So what is the way around? I did record it. Okay, so it's on record now. After the class, what I got to do, I got to put it in YouTube video. So, and then I'm going to put the link of the YouTube video. You can obviously see it with the caption. Okay, there is a CC option, you know, in YouTube video. If you click on, you'll be seeing what I'm talking. Is it clear? Okay, just want to clarify that. Okay, now is everybody done with the writing? The previous one. Should I move on the next one? Okay, perfect. Only reason I emphasizing on this whole through semester, I'm going to do it again and again because I can't share my class note anymore, right? The thing that you are seeing. You just have to put it in your note, okay? And you got to be diligent and serious about that. Obviously, you have the video lecture, but still. So if a particle has an initial velocity v0, just 1 second, what is happening here? All right, so initial velocity v0 is 12 feet per second. To the right, okay, what does it mean? Is say like a particle is moving from right to left, okay, where it does have a velocity initially is 12 feet per second, right, at s0. So at this position, so like this particle is moving from here to here, right? At this position, s0 is 0. You can say like, okay, your reference point is here, where s is obviously for position, right? You know that. All right, so s0 is 0. Okay, determine its position when the travel time is 10 seconds. Okay, the acceleration is 2 feet per second square, right? To the left. You understand from the sketch, right? What is going on? They're asking you to find the value of s. Okay, s minus s0 is s because s0 is 0, right? Initial reference point. All right, so let's just put them here as well. Anytime you see me writing a means acceleration, v means velocity, s means position, t means time. Is it clear? You want me to write that thing again, or you are familiar with that from physics class? Okay, again, a is acceleration, v is velocity, s is position, t is time. Anytime you're seeing any subscript 0 on any of these things, that means the initial. Okay, as an example, initial velocity, initial acceleration, initial time, initial position. Okay, 0 refers to that. So obviously you understand v0 is the initial velocity given also here. A is given as like 2 feet per second square, right? T0 uh, is given as 2 seconds. Initial time is 0, right? When it started, and this t after some time means this after 10 seconds, that's the time. What is the position? That's what they're asking. So you are doing what? You are doing the engineering format. You started with the givens, you had the sketch, now you have the find. What is your find? Means what you are trying to find here. You would like to find the position. So you'd like to find the position. You can write it in descriptive way after 10 seconds. Okay, and you want to say this after 10 seconds is s, the value of s that you are. Is it okay if I gonna take this call? It's really important. Okay, chill for 2 minutes. Hello. Oh shit. Yeah. What's up? Yeah, we are. I think we're in the train. Yeah. The mechanical engineering lab on Tuesdays. Yeah. And engineering materials. I think it's every Tuesday and Thursday. Let me see. Can't remember my schedule yet. Yeah. That's what I heard. Yeah. 127A. Yeah. I'm in your class. Oh, you are? Yeah. Yeah. Are you looking at the right one? Because that's the class beforehand. Are you in GD&T or no? Engineering materials. Yeah. Materials. 127A. Yeah. Yeah. There's a lot for a small room. Yeah, John. Yeah. I'm not sure if he said one day or. Yeah, that's good. We're learning. I'm graduating. Well, he didn't teach us any of the stuff that
switch it. This is weird. We tried it at 8 a.m. with Marcus. Yeah. I'm here too. I'm sorry. Yeah. It's because I don't know the class. My book just got processed. So I didn't know what was class and everything. I ain't gonna lie, you missed a lot. There's a lot to learn. Yeah, he told me. And next week I'm the first day of school. I'm gonna lock in.
Yeah, in engineering materials, he gave us a test and didn't teach us anything.
Oh yeah, like I tried to take it. I'm like, what the hell is all this shit?
Yeah, and so I just looked them all up. I don't know if it alerts him that I looked them up, but I don't know.
What does it do? What does it do today?
It was
yesterday.
Yeah.
Yeah, bro, I walked in the classroom and we talked. He was like, you just go up to your room. I'm like, okay.
Really?
But basically, like, there was a miscommunication between me and him because I thought he said to drop the class. Wasn't that what he said? He said to add another class. So I grabbed the handle, we talked, and I just left because I thought like he said. Then I saw him today. He was like, why didn't you come to class? I was waiting for you. Like, but you told him to drop the class. No, to add another class. You're fucking idiot.
Dang.
Yeah, we took, bro. We got like 25 minutes left. You on the phone. So this is it? This is the whole classroom? This is the whole classroom?
No, there's like a lot of people missing, I think.
Oh, okay, good. I'm not missed, bro. Friday, gonna be outside tonight. Life is good.
Just don't click on the AI assistant this time.
I was panicking, bro. Like, what? I was like, oh, it's my alarm. I go there. You got game today? You got game today? Oh, I'm muted. I'm server muted, bro. I get caught. You repeat. Hey, B. You have more headphones on?
Yeah.
You a deaf, but I hate you. You got varsity got games today?
Yeah, we have to, but don't you?
Oh, they both games only boys and girls?
Yeah.
Damn. Y'all play today?
Huh?
You play today?
No. I played the ninth.
The one like TV is fucking nasty, bro.
The
Yeah, bro. That one game I won like against Newport. Crazy, bro.
Snow day on Monday.
Oh, it's online though.
Oh.
I had to buy a 3D printer for this one class, man.
You did?
Yeah.
How much?
There was one for 179, but I was like, I went down for it, $400. I got a nice one.
I could give you mine.
Really? What you got?
I have 3D printers for Austin. You guys would have to give me $140 for it though. $140 and you would got it.
Yo, I cancel that shit right now. I'm gonna buy that shit out of here, because I bought my shit today. I'll cancel that shit.
I got my shit in the 3D printer. The other shit for $145. You got it.
What kind did you buy?
I bought the bamboo P1. The black one with the box and everything goes down.
The P1S or the P1P?
You got the
P1, not with the things inside. That shit was like $800.
you bought it for one semester. You can use it for
That's the one I had.
You can put it for multiple times, but like, are you really gonna use it?
Because like on the road, I thought about it like, yo, I do be 3D printing shit for my car and shit.
You do?
Yeah, at times. But then I'm like, it's for one class, because then I'm gonna have to like move it back and then back here, back home. It's gonna break something. And I usually just get like buy yours 140 and then for the semester. If it worked out well for you last semester when you took it.
Yeah. It's fine, bro. It's good.
Yeah, I have the P1P. That's the one without
Yeah,
Yeah, that's what I got.
Got the one of the good. You got one of the good ones. That shit cross spread.
well, I know. But then again, I'm getting math financial aid back like one was.
Oh, yeah.
Because bro, I'm in UOP, this one program, bro, and I usually get like $200 a semester, but they give me 5K this semester.
Really?
So that's half my bill right there.
Damn. Are you on campus or off?
Go huh?
Are you
No,
on?
I'm here in Swiss.
Oh, you're in over there.
Yeah, but like I feel like school's getting bigger, I guess. More funds are being available. I'm gonna consider that shit number 1 year ago. What you doing in that class?
Hmm?
What you doing 3D printing class? You just learning how to
We
3D print?
didn't really do anything. He kind of, it was a nice class because he just taught us,
How to level the
yeah,
Well,
you know how you like slice things and you can adjust it to 3D print it. He just taught us that, and then the final project you just print something with multiple pieces.
I'm sorry, guys. It's taking a little bit more time. Please chill out, okay? I'll come back immediately. Start. It's really important. All I'm trying to track that. Now the conference. All I didn't have any class. All 4 times. Now the conference.
I don't pass class. I'm used to deal with the phone all the time. Okay, that's it.
wait, it's a easy class. It is fun as well.
And I like Haskins. Haskins, bro.
Yeah, Eskins is a good teacher. Like even fluids, I like fluids, even though it's kind of hard.
Yo, I passed foods with a B, bro.
Huh? You didn't like fluids?
Nah, bro. I feel that class.
You failed it.
I understand it, bro. We're very confused.
The only thing I didn't understand was hydrostatics because I don't know.
You know how the final was like a bunch of questions and one question scores like 45 points?
Mhm.
Yeah, I like that's a question that I think it was like the last thing that we learned that I thought. But I took out with a B.
I think I think I only messed up with the pressure because I didn't add the pressure average or something.
Mhm.
I just canceled the pressures out, and you weren't supposed to. But I got an 84 on it.
Damn, on the final?
Yeah, the final.
Wait, Pete, do you need which one? Is it missing anything? Like filament or social? You print it.
Oh no, you need to buy a filament game. I didn't buy some. I just used the filament inside the 3D printer.
One roll of filament will last you the entire
I want to
semester.
get the carbon fiber one. It's like $30.
Oh, is it?
Yeah, but it's good. Like it's
Does it actually work on the furnace?
yeah.
It does.
Oh well, I gotta check.
What was it? It was what was the type of filament?
The P something P.
It's only one type of 3D. I'll show you it. I'll show you. It has my name on it. It says AP and John.
And John?
It's an AP and it's like my partner.
Oh, you
John.
got me?
Then are you taking the 3D modeling then? 3D modeling class that has this?
Yeah, 3D printers.
No, the 3D modeling.
Oh no.
She the 3D printing but not 3D modeling.
It's a lot.
I was doing the same thing, but not taking 151. I'm only taking lab.
Yeah, it's not required no more. Well, it wasn't even a requirement. I had to take the lab, but not the lab.
Maybe because I did it last, maybe because I did it at
Maybe,
college. Maybe that might be it.
Oh, me too. I have to take classes here in college, so maybe that should like equal it too.
Because I did AutoCAD, so it might be something, might be
Oh,
like equivalent to.
Oh, that's why. AutoCAD counts as a credit too. And then the AutoCAD here. And I took a 3D printing class over there. In Orange County.
You know what? Instead of you guys are sitting, maybe you may want to try something. That guy's holding me for a while. Okay, so you may want to try something here. Okay, you obviously want to try to solve it, but let me give you some direction so you can actually start doing it by yourself, right? So you are interested to find the position, obviously, right? After 10 seconds. So that's the main thing to do here, right? Okay. So the way you can do it is like you can use this equation, uh, but that equation can be derived. Okay, you can use this equation. So that's the solution. So you can use this equation to find it. A t square plus v0 t plus s0, right? So that's actually the equation. Like later on when you're going to do the math for homework or in exam, if I don't say like derive this equation, you don't have to, you just can directly use this one. Is it clear? All right, so you can use it directly, find the final position, but the interesting part would be doing the integration, finding the equation, right? So that's what, yes.
Does that say velocity t plus SO or velocity?
No, it's the t, the way I write t is this. Okay, it's kind of similar to plus. I'm sorry for that. Let's see if I can highlight. Okay, so these are the plus. Okay, rest are not plus. Let me see if I can even make it even further good. So this is my t, right? How about now?
Okay, yeah.
Is feeling better now?
Makes sense, yeah.
Okay, all right, perfect. Sorry. All right, so then what? Let's just um, give you some direction for the integration as well, right? So you'll have something at least good achieved today in a stormy day. Then when you come here, okay, everybody like everybody like to stay at home now. All right. So what are you gonna do? To find that equation, right? The equation that I showed it to you. So how to find that equation? So that's the, I would say on the side I'm gonna write it derivation, right? Okay, so on the derivation, you know acceleration is dv dt. The same kind of equation we'll be using all the time. All right. So then what? Just same thing, right? You would be moving things like, uh, a on the left and dv on the right. Okay. So a is the acceleration. You're doing the integration of acceleration with respect to time t. Okay. And if you do that, that's something we have done already, right? I'm gonna just give you the final form, which is obviously if the integration goes from initial velocity v0 to v, and the time goes from 0 to t, right? You have seen that. So these equation become v0 at. Is it clear to everyone? We have done this before, right? In last class. All right. Why we did that? Because we need to use this in the position equation, right? What is the position equation? So the position equation is ds dt equal v0 plus at, right? So what would be doing here? You would be again similarly moving things like this dt on the right side. You have v0 at, right? Okay. So what's your goal here again? Your goal is to find, this is s0 to s, the limit, right? And this is 0 to t. Your goal is to find, and that's the part I want you to do. Your goal is to find the equation of s, and you should be finding this s equal to s0 v0 t plus a t square divided by 2. So this is two things that I want you to do, right? In next 10 minutes. That way proper use of the class time. First, finish the derivation. Okay, integration that I'm showing it to you with the limits and everything. You guys are having a little bit confident with the integration now, right? Okay. So yeah, don't worry. If you can do that, I'll help you in person. If not today, in next class, okay? If time doesn't allow. But you try your best. And once you get this equation, all you're gonna do is just plug those values from the given, right? That's all. So that's all you're gonna do for today. Okay? And I'll come back. Okay? If not even you know what to do, right? You're doing good? You're doing good? There's some idea? So if I've been in a position, what I've been doing, like, separating this B0 and AP means you gotta do the integration by addition. You remember that, right? So V0 is a constant. Think about it, okay? V0 is a constant. So when you do the integration for V0, right? You don't do integration of V0. You keep the V0 as it is, and you will have like T will gonna come, lower limit 0 and upper limit T, so T will gonna come. That's the right side I'm talking. Obviously in the left side, you have S minus S0, right? For the integration, because upper and lower limit. Okay. I emphasized that thing in last class. If you have issues with integration differentiation, which could be the case for anyone, doesn't really matter. If you have a situation like that, I uploaded the basic equations for differentiation and integration in Brightspace. Review that. If you need the tutoring help, please go library first floor near help desk. They're going to give you a tutor. Okay? Because without integration, without the knowledge of derivation and integration, you will have hard time in this class to deal with the class material. Okay? You doing good? You found everything? You got the integration there?
I think so.
Okay, can see. You said once. You can run everything, so yeah. Let's see. And did you get the final value?
This one.
You plug the values like here, the S value. Plug in this. No, not this one. So once you derive that, obviously you would like to plug everything here to find the value of the S. You did it, right?
Yeah.
Okay, what's the value you got?
I got the final position to be 20 feet.
Let me see. Let me verify. So see, like if you got it, then you can go actually. So I don't want to hold you. Yeah, 20 feet is the final answer. So if you got it, you can go. Anybody can finish it, they can go. But please make sure you show it to me, okay? Okay, Gabriel? So say like a means to get from the I can marry right? Long as it's not that. But I don't have any all I need like not How everybody is doing? Anybody need help on the integration? You need? What's up? Oh, you got it? Okay, so DS also, you just have to separate these two, right? So the way you want to do, first of all, this is S0 S, right? And this is 0 to T, that's the limit. So this S0 S DS means what? This is S, and then you have S0 and S. You know how to do it, S minus S0. That's the integration, upper and lower limit. Okay? That will be similar to that. Okay, S minus S0. Upper limit, lower limit. Upper limit minus lower limit. On the right side you just have to do 0 to T, V0 dt. That's this part. And the plus 0 to T, AT dt. So this A you can move it here because this A is constant, right? This T is T squared divided by 2, right? So 0 to T. And this V0 you can move it here. This is T, 0 to T plus. Make sense?
I'm learning this right now in Calc 2. They learn this in Calc 2, so I'm like, I'm not, I don't understand it. You're not learning it right now in Calc 2.
It's all right. It's all right. I mean, there's no nothing like to be sorry about or feeling bad about or anything. You can do that. We are here to help you. Okay? Don't worry.
I'm learning it right now.
You're learning, so you'll be falling behind. I understand completely what you say. But my suggestion would be at the same time you want to get a tutor right away because you are doing two courses the same thing. That would be really helpful to you. Okay, spend a little bit more time on this thing. Okay. If I'd be in a position, I'd be doing that.
Well, if you can get a tool together, we're gonna do the same thing.
Yes.
I got 20 feet.
Yep, that's all. But this is the derivation you'd like to do from here to here. Okay?
Yeah, we're gonna get a tool to run down with it.
You're doing good? You have any question? How do you get 23?
Yeah.
Or is it once you plug all the values, you should get your say like A value is given as like 2, right? And the T value is given as like 10. So 10 squared is what, like 100 divided by 2 is 50. 50 multiplied 2 is what? 100 plus 12. Oh, you're getting more than that, right?
Yes.
So that's the thing. I don't know how others get 20. Let me check.
I got 220.
How much?
That's what you got?
How do you get? 220.
Yeah,
it
I
should
got
be 20. It should be 220. That's all. It should be 220. I might be giving the wrong answer. What was the value you got?
I got 220.
220. It should be 220, not 20.
Alright, that's what I mean.
Yeah.
Yeah. I was like,
Yeah, 220 is the right answer. I'm sorry. I missed it.
And quick question for the homework. Do you want us to engineering format or just normal paper?
Engineering firm, please. Everyone. And I didn't upload the homework yet because we are not here yet.
We are not there.
Yeah, we
That's
will
fine.
from next class up. We will be
Yes, Monday, whenever you're teams,
Yes, come here. What's up?
because I know they cancel class on Monday. For the weather.
Oh, they cancel?
Yeah, because the
Monday,
weather.
everything's canceled.
Remote.
Yeah, everything is canceled.
That means it would be remote.
Yeah.
Man, so I gotta do it anyway.
So we're gonna be online or we're gonna record?
Online, I'm gonna do it in Teams. Maybe a shorter class. I really don't wanna do a very heavy stuff, but it would be like smaller things. Okay. Okay. All right. Oh yeah. About that. Just wait a little bit. Let everybody go. It's personal thing.
Oh, it's remote because it's snowing.
Oh, okay.
So depending on your professor, if they're gonna do like a video or they're gonna do Teams.
I wish it was Tuesday because I have 4 classes on Tuesday.
You never know, but it's gonna be a crazy weekend.
Yeah.
Take care, bro.
All right. So as no, still. Just wait.
So I talked to Dr. PS,
Yes.
and there was a miscommunication between me and him.
Yes.
And yeah, I talked to him today.
Yeah. I heard about it.
Yeah, I talked to him today. It was a miscommunication. And
Yeah, Arlen, I gotta talk with him. It's private
Oh.
thing.
Oh, okay.
Still.
Oh, okay.
It's sensitive things.
You gotta wait on site.
Just for me. 1 minute. 1 minute. I gotta convey that very important message. So this office told me you can take the additional course because of your status AP.
What do you mean?
So,
AP?
let me. I was so like there are the limits for the course. So
For statistics?
yeah, I mean your credit hours, the credit hours limit. Okay,
I will be at 16, and I'm above a 2.0 GPA.
you're above.
Yeah,
It is showing not above. Probably that is the reason.
because I took winter classes, and they put me above 2.0. That's why I got financial aid back and everything.
Okay, so here's the thing. 16 credit hours,
Yeah.
and you are in AR,
What's AR?
academic recovery.
But I'm not no more,
And
because
to
I'm
drop.
over. I'm over 2.0 GPA.
So that's the thing. Let me see first. Okay.
Mm-hmm.
I just don't wanna go with